This is part 2 of section 10.5, the laws of sines and cosines. We had just finished practice 2. We're now on example 3. Solve the triangle given. Round decimal answers to the nearest tenth of a unit. Here we have triangle ABC. We're given 2 of the 3 sides and 1 angle. The pattern here is we have a side, and we have another side, but we have an angle in between it, so it's side, angle, side. That's our pattern. So we try the law of sines first. So that's plugging in these values here. We have lowercase a across from angle A. That's 11. B here is across from 34. And C, lowercase c, is across from angle C. So that would be C. So starting with A, lowercase a, 11, over the sine of angle A, which we don't know, equals lowercase b, which we don't know, over sine of b, which is sine of 34 degrees, equals c, which is 14, over angle c, sine of angle c, which we don't know. Notice that none of these three have both numerical values in both terms of the ratio. We can't use the triangle angle sum theorem because we only have one angle. So what do? When the law of sines doesn't work and when there's no other previous way to get any of these numbers, then you use the law of cosines. There are 3 cases for the laws of cosines, depending on your setup and what you're using. Notice that we have angle B, so we want to make sure we use the law of cosines that contains B, angle B. That one starts off with b squared, lowercase b squared. Recall that it's b squared equals the other 2 sides squared and added together, a squared plus c squared, and then subtract 2 times these 2 lengths multiplied together, AC, and then times the cosine of the angle that's the same length as this one, or opposite. So cosine angle B. So this is the formula we're going to use. Now when you use law of cosines, it's real easy, if you're not careful, to get wound up or tangled up into the calculation part. It's best, it's been my experience, I've noticed it's best for you to plug in the values, of course, first of all, but then instead of putting it all in your calculator, many mistakes are made that way, try to simplify it as much as you can. So I'm going to show you some ways to do that as we go forward here. So on this one, we take b, lowercase b, which we don't know, that's what we're looking for, squared, equals lowercase a, which is 11, squared, plus lowercase c, which is 14 squared, minus 2 times a, which was 11, times c, which was 14, times the cosine of angle b, which we do know is 34 degrees. Notice in this particular problem we've got all these values over here substituted in, and we're solving for b. Next, we very accurately and methodically start simplifying. Cosine of 34 needs to be the very last thing that we take care of. 11 squared is 121, plus 14 squared is 196, minus, and then you can multiply these 3 together at one time with your calculator. That's 2 times 11 times 14 is 308, times the cosine of 34 degrees. Next, go ahead and add these 2 to make it a little simpler. B squared is equal to, when you add those 2 together, you get 317 minus 308 times the cosine of 34 degrees. At this point, there's really nothing else we can do to simplify without a calculator. So at this point, it's a good time to go ahead and use your calculator. Make sure you're again in degree mode. We have 317 minus 308 times, or just the cosine of 34, close parenthesis, enter. And we get about 61.7 equals b squared. Now don't forget, this is b squared, not b. So we must take the square root of both sides to get rid of the square. So we take the square root of both sides. This is obviously going to be another approximation. And so the square root of 61, about 61.7, is approximately 7.9, rounding to the 10th place, 10th of a unit. So that means that b, this side over here, we've solved for that side, is 7.9 about. Now we still need to find these two angles. Let's come up here and replace b with 7.9. Now we have one of our ratios in the law of sines. We have both the numbers, so we can use this one with one of these others to find either angle C or angle A. After we do that, then we can simply use the triangle angle sum theorem to find the remaining angle. So next, we're going to use the law of sines at this point, and I'm going to bring this up here. And I'm going to use, doesn't matter which one, I'm going to use 11, the A. So we have 11 over the sine of angle A equals, and now I'm going to use this new 7.9. 7.9 over the sine of 34 degrees. So now we cross multiply and we're back to the law of sines. So I'm going to go this way. Notice our variable is angle A here. So we have 7.9 times the sine of angle A equals, cross multiply this way, we get 11 times the sine of 34 degrees. Since we're solving for the measure of angle A, we need to get rid of the 7.9 that's being multiplied with the sine of angle A. So we divide both sides by 7.9. The 7.9 divides out. So we get the sine of angle A is equal to 11 times the sine of 34 degrees over, or divided by 7.9. At this point, we're not going to take the arc sine yet until we get this to be a decimal. But at this point, we have the sine of angle A is approximately equal to, let's get our 4-digit decimal now. Make sure you're in degree mode. We have 11 times the sine of 34, close parentheses, don't forget to do that, divided by 7.9. And we get, rounding to 4 decimal places, about 0.7786. Now we can get rid of the sine on the angle by taking the arc sine of both sides. So we take the arc sine of the sine of angle A, and then we have to do it on the other side. Take the arc sine of 0.7786. Arc sine and sine cancel each other out, and the measure of angle A is about 51.1 degrees. You can do that in your calculator. We've solved our triangle, and we found our second measurement, 51.1 degrees. So I'm going to put that in here. 51.1 degrees in parentheses. You can do that too. And then I'm going to come up here to my original and go ahead and replace the measure of angle A with 51.1 degrees. Finally, we've got two of the angles. We can find the third one by triangle angle sum theorem. Now we've approximated, so everything is approximately now. So the measure of angle C is what we're looking for, plus measure of angle A is about 51.1 degrees, plus B, which is 34 degrees, is about 180 degrees. So adding those two, we get the measure of angle C plus about 85.1 degrees is about 180 degrees. Then we subtract 85.1 degrees from both sides, and the measure of angle C is about 94.9 degrees, a little bit more than a right angle. There's our third answer in solving this right triangle. So right over here I write 94.9 degrees. There. So B is 7.9, the measure of angle A is 51.1 degrees, and C, the measure of angle C, is about 94.9 degrees. We've solved the right triangle, or the obtuse triangle. Example 4, Archaeology. An organism's step angle is a measure of walking efficiency. It measures walking efficiency. The closer the first step angle is to 180 degrees, the more efficiently the organism walked. The diagram shows a set of footprints from a dinosaur. Find the step angle B. Of course, step angle B is the second step, just like they did, or the first step from the original after the dinosaur footprint in the sand or rock. The diagram shows the footprint of the dinosaur. Find the step angle B. So that's this one right here. Then find the third step angle, which would be this one right here. Before we get started, there's one thing you need to be cautious about. When using the law of cosines for an obtuse angle and you've got all three sides and no angles at all, this would be the side, side, side pattern. You've got to be very careful to make sure that you always find the obtuse angle after you find one of the acute angles. So, here we go. If you try to use the law of sines here, it's not going to work because all three sides are here, but none of the angles are here. And in each ratio of the law of sines, there's angles in all three ratios, so we can't use the law of sines. So by the law of cosines, now we're going to find the measure of angle B first. We have the measure of angle B, and so we're going to use lowercase b. There's three forms of the law of cosine. So we have b squared equals the other two lowercase letters, across from those angles, a squared plus c squared minus those same two multiplied together, multiplied with 2ac times the cosine of the angle across from this side, angle B. Okay, this time when we substitute in values, last time we were looking for little b. This time we're looking for angle B, but we still plug it in the same way. So let's identify our sides. Across from angle A is lowercase a, so that's A. Opposite angle B is lowercase b, right there, and across from angle C, lowercase c. So b squared, that's 316. Squared, and then we have 316 squared equals, and then 316 squared equals a squared. Let's see, a is 155 squared plus c, lowercase c, side c is 197 squared minus 2 times a, which is 155, times c, which is 197, times the cosine of angle B, which is what we're looking for. Right there. Okay, well, from this point on, we go ahead and substitute in our values and try to isolate the cosine of angle B. So these are rather large numbers, so be very careful in your calculator that you put them in correctly and write them down correctly. 316 squared is 99,856 equals 155 squared is 24,025 plus 197 squared is 38,809 minus, we can multiply these three together now, 2 times 155 times 197 is 61,070 times the cosine of angle B. And then we can go ahead and add these two. We have 99,856 equals, when you subtract those two, you get 62,834 minus 61,070 times the cosine of angle B. At this point, we have basically our equation is simplified as much as we can. So we start solving, getting B by itself, angle B. So the first thing we need to do is get the 62,834 rid of. So we subtract 62,834 from both sides. That gives us on the left side 37,022. These go away, and we're left, don't forget your negative, negative 61,070 times the cosine of angle B. At this point, since this number is multiplied with the cosine of angle B, we get rid of that number by dividing by negative 61,070. Remember, you have a negative, so you divide by the same negative. We have to divide the other side by negative 61,070. At this point on the right side, those divide out, and we're left with cosine of angle B. On the left side, we take 37,022 and divide by negative 61,070, and we do get a negative value, negative, and 4 digits. I don't need that parenthesis yet. We get negative 6.6020. Well, at this point, you've seen this before, except without the negative. But we do have to put in a negative this time. I'm going to move this over here, use symmetric property. I'm going to write cosine angle B equals negative 0.6020. I have to get rid of the cosine on the angle B. The way I get rid of that is I take the arc cosine of the cosine of angle B. I did that over here. These do away with each other, and we get the measure of angle B. But on the right, we have to do the same thing. The arc cosine of negative 0.6020. And so, this gives us an approximation. In your calculator, you're going to put in the arc cosine of negative, remember the negative key is at the very bottom, don't put in the minus key, 0.6020, and we get approximately 127 degrees. I want you to notice this is an obtuse angle using the law of cosines. Many times you're going to have a negative value when that happens. So anyway, we found the measure of angle B. That's our first step angle that they asked for. So this is your first answer right here. This angle right here is about 127 degrees. So its walking efficiency is getting, well, a little closer to 180 degrees. Fairly efficient. The last part I want you to do, it says find step angle A, the third step right here. Turn off the video, use the type of method that you think should be used, and turn it back on when you're ready. Okay, to find the measure of angle A, notice that since we've already found the measure of angle B, we know that this is 127 degrees. Well, we have enough to use the law of sines, and so you could have used A over sine A equals B over sine B. Since we didn't have angle C, we weren't really interested in that. So little a, or lowercase a, is 155 over the sine of angle A equals, lowercase b was 316 over the sine of angle B, which we found previously 127 degrees. And then did you cross multiply it? 316 times the sine of A, angle A, equals 155 times the sine of 127 degrees. At this point, you would divide both sides by 316 to get rid of the 316 on the left side. So all we have is the sine of angle A. And at this point, we use our calculator. 155 times the sine of 127, close parenthesis, divide by 316, gives us approximately 0.3917. At this point, we need to get rid of the sine, so we take the arc sine of both sides to get rid of the sine. So the arc sine and sine cancel each other out, and we get the measure of angle A. Our third step angle, the one that asked for, is about, the arc sine of 0.3917 is approximately 23 degrees.